Sequential sampling models such as the Drift-Diffusion model or DDM have become prevalent in recent years across many fields of research, including psychology, neuroscience, economics, and marketing. For preferential choice, such models are driven by the relative value estimates of the options. These models do not, however, consider subjective feelings of certainty about the value estimates, even though that has been shown to have a clear impact on choice behavior in recent studies. Here's an example of the paradigm used in such studies. The first task is a rating task where individuals are shown different options, in this case food. They're asked to provide a rating or a value estimate for each option. Then they're asked to provide a measure of certainty about the value estimate they gave. They do this individually for a series of 100 to 200 different options. Then they move to the choice task. Here, they're shown two different options on the screen, and they simply click on the one they prefer. What we found is that value estimates are indeed uncertain, and in particular, each value estimate has its own degree of certainty, and participants are able to report these different certainty levels. And more importantly, choice consistency and response time are both enhanced by these feelings of certainty. Specifically, the way certainty impacts choice is that higher certainty across the pair of options leads to more consistent choices, and greater certainty difference leads to a higher probability that the option with a higher certainty will be selected. And both certainty sum and certainty difference correspond to faster responses. The next question is, which parameter of the DDM would need to be modified in order to be able to account for these effects? So I show here some qualitative simulations of modifying each of the different parameters individually. So in blue, we see that increasing the drift rate increases consistency and decreases response time. In red, we see that increasing diffusion noise decreases consistency and decreases response time. And in green, we see that increasing the response boundary increases consistency and increases response time. When we look at the experimental data pulled across 4 previous studies, we see here that an increase in certainty sum and certainty difference both lead to an increase in consistency and a decrease in response time, suggesting that it should be the drift rate that's modified in the DDM to account for the empirical data. To be complete, we tested a variety of different models. We start with model 1 as the basic standard DDM. Model 2 is the basic DDM, but certainty decreases the diffusion noise. In model 3, certainty decreases the response boundary. In model 2+3, certainty decreases both the diffusion noise and the response boundary simultaneously. In model 4, the certainty increases the drift rate. And in model 5, certainty modifies the value estimate before it's compared to the other value estimate. And then this impacts the drift rate. As you see here qualitatively, model 5 is the only one capable of matching the empirical data. More quantitatively, we did a formal model comparison in which we first fit the data from each participant individually under each of the models, and then we did a comparison of the output. Here we see a plot showing the probability that each model was best per participant, and also the probability that each model was best across the population, and clearly model 5 dominated. Finally, we did a test of model recovery that showed that if we simulated synthetic data under each of these models and performed the same sort of model comparison analysis, we are indeed able to recover the true generative model in the vast majority of cases. In conclusion, we showed that a DDM with the drift rate modified by value certainty can account for the empirical relationships between certainty sum and certainty difference on both choice consistency and RT. And we propose that researchers in the future might want to consider using this type of DDM to better account for their choice data, assuming they're able to collect measures of value certainty. Thank you very much.